Okay, so replace the leaf batteries, leaf modules into the bay, making sure that the positive most terminal is on the left-hand side of the motor controller, which puts the negative most terminal at the rear or at the front of the bike. On this particular motor controller, it was an old version with the old steel studs on the phases, so they've been swapped out with the copper phase terminals. If you haven't done it by this point, you probably should, because getting access is fairly painful. Ideally, this should be done before the leaf modules go in. Okay. At this point, I've also glued in the mount for the display. This takes quite some time to dry. I just use black silicone. I tend to give it 24 hours, so that's probably the first thing I do before I take the bike apart. On this particular bike, we've installed a TC charger, one of the new ones, the ultra high frequency units. So I have a separate video for installing one of these, but if you got your original ESD charger, don't worry about some of this more difficult stuff. If you have got a TC charger, I'll actually install two fuses, both 200 amp units, one at the negative terminal, one at the positive most, and we won't need the one on the motor controller. The positive lead from the original motor controller positive lead is fed through the blue current sensor directly onto the IGBT module on the motor controller. The negative most lead is one of these blue Anderson connectors that I've cut in half so it can plug into itself, and I use a second identical blue Anderson connector to plug into the negative most terminal, which I've pre-done here with fuse, shunt if you're using a current sensor, and blue cable. Okay, I'll send this to my assistant. So now for the fun part. I may have made up for you the interconnect sets with the pre-wired BMS plug. Now on a couple of these, you will need a little bit of modification around cutting away the plastic so you can bolt down or get underneath the fuse. Which is the best one for this particular job? Probably this one. So I just use a pair of little snips. These are quite cheap, they're $2 off AliExpress. I'll just cut away at the plastic that's in the way, taking care not to cut any of the wires, because patching them in is very, very painful. And when I say painful, I mean difficult. The plastic isn't particularly strong, it's quite soft. If you haven't seen a Leaf battery come apart before, these are what's installed on the Nissan Leaf inside the battery. Okay, next part is to put it on. So, they won't all line up first go, and that's okay. What you'll probably need to do is push the battery in. So it bunches up a bit. What's probably advisable at this point is to have your box of screws ready to go. Which is something that I didn't do. Pause the video for a second. Right, back up.
Yep.
Alright. For this particular bit, it's going to be a good idea to find somewhere to sit down on something. I use my toolbox. Otherwise you would do your back in just bending over all the time. Now, the trick to getting this all on is populate the bolts on the first couple. You don't have to tighten them down, finger tight's fine. You're just putting them in to locate. So you probably can't see from the video so well, but these haven't quite sat in, or did on that side. And the trick is, you push it over. There we go. Then you tighten that down a bit further, just so it doesn't pop back out again. And then do the next row. Oh, forgot to mention earlier, so with 18 modules, there's a little bit of a gap either side. I pack in a bit of foam. Once they're all bolted together, it basically moves as a block. They stay pretty well. They stay pretty well together, but it does put a bit of pressure on the terminals if that's the only thing holding it. Whereas if you pack in foam in the sides, it gives a little bit of extra pressure at the bottom. Okay, back to carrying with this. I learned a new phrase the other day. It's called finessing it. It's a little bit tedious, but it gets the job done. Next row pushes in. Now this last module is going to be difficult because it's actually the wrong one, so I had to face it in the other direction. These older leaf modules come in A and a B, where the terminals are on opposite sides. On this particular bike I had 18 modules, but I think I had 9 of one type and no. Right, I think I had 11 of one type and 7 of the other, and so I was always going to have one that's the wrong way around. It does still fit, thankfully. It's just a little bit more finessing involved, or mucking around. I generally do the fiddly bit with the fuse last. On a normal build where you can keep the original charger, I would only have one fuse instead of the 2. The only reason I'm running the 2 fuses is I have 2 lengths of wire going across the battery, and if any of them wear through and short to the battery, it needs to be able to blow on either side. Generally, I'd probably have the fuse up this end. Okay. There it is. I generally use a drill with the torque limit function to do up the bolts, just so that they're done in a consistent fashion. The beauty, of course, in doing that is it's very quick. Doesn't take long at all to get through. Ugh. Okay, that one's done. I'll generally come back for the middle ones. The middle ones will just line up regardless, but they involve a Phillips screwdriver. Next one. The middle one is usually not a problem. It just works as is. Best way to do this. Probably start at this end. Same sort of thing, populate one end first. Shift it forward to get the next. Now, I forgot this earlier, the end interconnects won't be in place, so they need to be placed. Be careful when handling them, because if you drop them on the live section, it will be very, very exciting. Not for a good way. So you just slot it in. There are actually clips holding it, but you can slot them underneath. You always want the interconnect to go underneath the sense wire, because you don't want the sense to be in the middle between the high current connection. Get the next one in. This is generally easy to do if the modules are bolted together. But the only problem with bolting the modules together is when you're loading them into the bike, then you've got to do them sort of 6 at a time, and it gets to be quite heavy. 6 modules are about 24, 25 kilos. I have no idea what that's in pounds. I'll have to look it up. Right, and then this is a little bit tricky. Push it in. Oh, jeez. There we go. Once it's located, it's not too hard to tighten all back down again. All right. What's the next part? Quick center. Okay, now the last little bit, you can see that the modules are on a bit of an angle, because the first 12 have been crushed together. So what's a good idea to do now is to put this hand down. Oh, if you can get it down. What we're trying to do is push the modules up. So then with the rest, it's not a bad time to shove some more foam down there either. Just to make your life a little bit easier when it comes to getting this connected up. Okay, so lucky last. Now, and again, just like for the positive most terminal, negative most terminal will need to be cut out, at least the plastic around it. Again, my favourite little $2 snips. Probably doesn't come out well on the video, but you can see all the little joins that held it together. So there's actually not that much that needs cutting away to get the effect that we're after. Whether you have access to them is a separate matter entirely. Because the plastic's soft, it also work hardens very quickly. So if you can't quite get to the spot you need, you can just flex it. It'll come off. I think that's good enough. Let's test it out by putting it on. See if I can get the shunt onto it. Generally I pre-wire all this before getting to this stage, just because once it's in there, you can't get a pair of a socket set in there to do anything with. It's very painful indeed. Again, sense wire on top first, and then I need a lengthy bolt for it, which I forgot to bring. I prefer to do this negative terminal up first before the rest of it, just so you're not working on this end live. Once you fully populate it, then there'll be 140 volts or so between these two terminals. Alright, so next part is to cut a hole in this little fake vent to get the cable, CAN bus cable for the display through. So I normally grab a blank connector, or even a cable with a connector already on it to get a rough size. And then I use my trusty tin snips to cut on through. This vent used to sort of beat a heat out for the charger, but the size of the holes is so small that it's really made no difference. Again, plastic's fairly soft, so you can sort of work harden it off. And that goes through pretty well. Push it on through. Okay. Alright, so we're up to the stage where we want to put in what I'm going to call the control box. So that one's going to be a little bit hard to see. This is one that I also repaired. So you got the EVMS master. I'll talk you through a bit of the components. You got capacitors, so that when you turn the bike off, it's got enough time to save your fuel gauge status before it goes dead, and what have you. Now, depending on what charger you're running, if you're running an original Vectrix charger, or one that is not communicating via CAN bus with the BMS, you will have a relay and probably a 12 volt power supply if you're not using a TC charger. On this particular bike, we're using a TC charger, which supplies 12 volt, and the BMS communicates via CAN bus, so there's no need for the relay. Much simpler installation. In either case, it's now best practice to mount the control box underneath the boot. For getting better access for this particular job, I normally unscrew the spring from the side here using normal Phillips. That way I'm not having the boot constantly falling on my head. It's a bit of a pain. To affix the plastic box to the plastic case, what I normally do is use what's called nutserts. You might also know them by the name of riv nuts. I just use a 6mm bolt usually pre-drill into the plastic case first, and then drill through holes individually. So I drill a hole, usually the same size, so I use a 6mm hole, a 6mm drill, drill through, put a bolt in, drill the next hole, put another bolt in, so they're all four of them in the right location. Then I drill them out. So for an M6 nut cert, I use a 10mm drill bit to then drill out the hole to put them in. Alternatively, you can leave it as a 6mm hole and then try and get a nut in the other side. Sorry, just in here. It's after the first time taking the plastic case back off again and losing a nut, it's not something I like to do, but it's all right in a pinch. It's just very, very fiddly to get a spanner down in there and hold it in place while you're screwing it in with a nut. The other thing I need to do is drill holes to let the cables through. Now I try to keep them quite nice and small, and then I silicon them up later to keep the waterproofing. On this particular model with the TC charger, you need a CAN bus line, so what's called a high voltage sense line. So I usually pick up off the motor controller 2 wires to go back to the EVMS master, and then I have to pick up 12 volt from the front of the bike. So to pick up 12 volt, I piggyback off the back of the DC port, or the 12 volt port that's in the back of the glove box. If you're buying my kit, I'll supply this particular bit of wire that goes all the way to the rear of the bike. So it's just a plug and play. The only problem with this particular method is I can't have connectors both ends to feed the wire through. One end needs to not have wire. On this particular conversion, I've set it up so that this end is the wire that got pushed through, if that makes any sense. It just means I need to terminate the cables here, which is a lot easier to do than in the guts of the bike. Okay, alright, for this particular job I like these sort of wire strippers. I'm not sure if I've brought them in before. They're nothing particularly fancy. You should be able to get them from Radio Shack or Tandy, or most hardware stores will have them. They're just wire strippers. It speeds up the process than trying to strip the wire manually. So this one, from memory, is CAN bus. So I'll supply a connector for it. This one's not too bad. The ordering of the wire is generally black, white, blue, red. If you're ever unsure about the order of the wire, look at the other connectors that are supplied. It'll be exactly the same. Strip a little bit off. Whoops. You only really need about sort of 6 or 7 mil, or 1/4 of an inch of wire stripped. Before you start cutting the wire, it is good practice to make sure they line up, they're particularly level. If they're not, cut them until they are. Alright, pause for a minute. Okay, so start with the red on the far right, with the screw terminals facing up. Slot them in. Generally the plug will come where it's already unscrewed, but if it isn't, then make sure you unscrew them first. You might need a little jeweler's screwdriver to be small enough to get in there. Alright, so that's one. Next wire is the high voltage sense wire. This particular one, we'll need to use these little red U-crimps. For this particular job, I tend to like, same deal, strip the wire. I've left probably a fair bit of length on these wires, which I'll just coil up inside the case. The reason being is so that then I can pull this out clear, rather than having to bend in there if I ever have to work on it again. Like so. Pause. Okay. For crimpers, I tend to like to use a Ratchet Crimper, partly because it crimps on multiple locations, rather than your cheap automotive one where it crimps in one location. Just makes for a better join. If you don't have a crimper, you can solder it instead. That's perfectly fine for this particular job. Oh, that one's a bit tight. Perfect. And just got the wires out of order. It's very easy when you're doing it for some of the wires to switch over. Which is a little bit of a pain, because to take out an individual wire is really difficult. It's sort of all or nothing, without damaging the insulation or putting an undue stress on the wire. Try that one more time. Not too painful. Alright, the last wire, at least on this particular version, has a 12 volt from the back of the DC port plug. And the 12 volt from the charger as well. So I'm actually going to give myself probably quite a lot of wire to work with, just because they'll go to different points. Stop filming. Yep. So these smaller wires will need the U-crimps on them as well. Tricky thing with small gauge wire when crimping is sometimes they break. If you have trouble crimping this particular wire, it is probably better to solder it. Normally when you solder, the wire becomes brittle and hard, which means that you need more mechanical protection to stop it from vibrating loose, because it work hardens really quickly. But because it's inside the box and the gland is already restraining it, it's not really as much of an issue. You want to make sure you're crimping on the copper only, not on the insulation. Oh, sorry. So I tend to give myself quite a bit of stripped wire to work with. The old tug test is good enough to see whether the crimp's good or not. Alright, the next fun part. The way. I tend to like to heat up the soldering iron ahead of time, and it's better to have it and not need it than need it and not have it ready to go. Having the extra bit of length on it means that I can pull the wires up or pull the case up and work on it from a better angle. So in this particular bike I color coded it, so red is 12 volt from the charger. If you're using the other unit where you got the relay and the 12 volt power supply, 12 volt power supply will already be pre-wired to the EVMS master, in which case the only thing you're doing is connecting the 120 volt AC or 240 volts AC coming in to the 12 volt power supply, but I'll detail that in a separate video. Okay, so 12 volt from charger, I just put on the 12 volt DC rail, or terminal rather. On this bike it's pretty crowded, but you can fit quite a number on there. Now the other two, I'll leave off for the moment. When I power up the bike, I'll test polarity. It's not overly well documented, the polarity on that DC port. And between bikes it does seem to change or swap over, so there's no set way around that to normally go. You have to power it up and test it. Sorry, back on the box. CAN port, easy enough. There's plugs for it to plug into. Just plug it in. Oops. Oh, the screw side tends to go down. High voltage sense. So generally I'll use the brown or the red as positive, blue or black as negative. And they just go HB positive, HV negative. What these allow the BMS to do is measure the total pack voltage separately to using the addition of the cell top modules. Okay. Alright, and the negative from the charger, which will be the black, as soon as I crimp it. Oh, come on. Goes to what's called charge sense. So it's the fourth terminal. So what this does is provides a negative, which the BMS then interprets as being in charge mode. Okay. Now next step is pre-charge. So generally the charger shouldn't need pre-charging. Just hook it up as is. Not a problem, but the motor controller does. I generally use a like load. That's the easiest way to do it. This one I made it a little bit tricky for myself. Right, so one end just needs to clip onto somewhere. Actually, there's fine. The other end needs to clip into, one option is to shove it down the back of, oh, that's not going to work. What to do? What to do? Normally I'd clip it to this, but there's a boot in the way and that took me ages to get on, so I don't really want to get it back off again. Yeah. Alright, so to get around this problem I've used a multimeter probe to push past into the insulation, into the actual conductor material, provide a space to clip on. Assuming this globe's any good. Why didn't that work? You're kidding me. Alright, let's put a probe through. Now, you might have missed it, but the globe glowed for a second and then disappeared. If it doesn't glow for a second, then don't connect the connector. But in this case it did, so all is well. And then once the connector's together, pull the probe out and unplug the globe. Now I really should have put a bit of tape over those terminals, because if they shorted to the battery that could have been very exciting. But oh well, oops, too late now. Alright, so first thing is to check, does the bike power on? Which it did. For you. Next step. If you got probes like these that are 1000 volt rated, generally they'll have a little cap over the actual probe, which is where I got this from. It's really easy to lose the caps, so I'll put it back on as soon as you used it. Alright, next fun part. Testing the polarity on these two cables. Most multimeters, if you have the cables the wrong way around, will show negative. This one's not, so the blue's the positive and white's the negative. On your own bike, it'll be different, but you'll just have to measure it. Alright, so blue's positive. Good to know. Turn the ignition off. These go dead as soon as the ignition's off, so then they're safe to work on. Positive goes into key in, which is the third terminal. Come on, get in there. And the negative just goes into the ground. Too easy. Alright, so the next step is to plug all the BMS plugs together. So just be aware that this is all live. Normally I'd have the orange covers that go over these terminals, but I don't have them right this very second. Pause. Now we're plugging the 12 cell modules into the battery. It doesn't really matter whether this is before or after you've connected up the charger and motor controller, because it's from the 12 cell perspective, it's live anyway. Before you plug in, just double check that this end of the plug is negative and this end of the plug is positive, matching what's on the module. If it's backwards, it'll smoke and it'll be very expensive to fix. So this one, I can see this wire comes off the positive most terminal, so we're good. Just snaps in like so. And you go and do it for every single one. Then we're running the CAN bus wires. It doesn't really matter what order the CAN bus wires are done in, as long as they all connect. Okay, next step is to turn on the ignition.
Yeah.
Okay, so turn the ignition on. Power up like so. Now there's a switch on the front. In the middle position it's off. One position it should be drive, and the other position should be not drive. Now that's interesting. It's doing nothing, so I wonder what's going on. This is where the troubleshooting comes in. So, if it doesn't power up, only one or two things are happening. Check HV to make sure that's coming through fine. Yep, that's okay. So no 12 volt. It's very interesting. Oh, how did I, what? Oh, that's the wrong way around. So I measured between ground and key in, and it was negative 12 volts, which is obviously wrong. Which means somehow the 12 volt wires I measured earlier are in fact the wrong way around. Bit strange, but there you go. Easily fixed. Having those two wires the wrong way around doesn't cause damage. It just doesn't work. Luckily. All right, try again. That's better. Alright, so this is in running mode. If it starts out in running mode, the switch on the grey box, or the white box, you need to switch over. Oh, no, I wired it up wrong. I'll try this one more time. Stop.
Okay.
Okay, so the positive from the bike actually goes to this switch. Lets you switch between idle mode and drive mode. You need to go into idle mode to set the parameters on the BMS. But yes, that was silly earlier. So bike on to get 12 volt up. that's running. Idle, that's what I want. Okay, so I want to enter setup. Pack capacity. On this one, these leaf modules are a bit on the old side, so I'm going to put conservatively at 35 amp hours. That's just for fuel gauge, driving only, it doesn't really do anything else. SOC warning at 20%, so I can probably put that to 40, 20% is fine. So this is the state of charge at which a warning will come up saying that you're running low. Full voltage is the voltage at which the fuel gauge will reset to full. I'm going to set it to 146 for 18 leaf modules. Warn current is not something that's useful in this situation, nor is temperature. Minimum auxiliary voltage I'll drop down to 9 volts. It's not really relevant in this situation either. Isolation. So this measures isolation between pack positive and pack negative and the chassis. On the Vectrix, from memory, I don't think either side are tied to it. It's good to check anyway. Tacho doesn't really matter because we're not trying to drive a tacho. Fuel gauge full. This is when driving an external fuel gauge, again not relevant to a Vectrix. Similar to fuel gauge empty, or temperature gauge, because there's no temperature gauge. BMS minimum voltage for leaf batteries, I would set this to about 3 volts. It just means that if any cell goes below this voltage, a warning will come up. Bms Max Voltage, 4.15 is what I would set it to. So it means that if any cell voltage goes above 4.15 volts, the charger will shut down. Now, balance voltage. You have the option of setting it to dynamic. So what that means is any cell voltage that's above average will have a little 0.1 amp load attached to it. Basically the whole time you're either riding or charging. If you set it to a specific voltage, it means that balancing will only happen above that voltage. Dynamic's pretty good, so I'll leave it there. Bms Hysteresis, or Hysteresis. So if a cell voltage is only 0.1 volts above the rest, it needs to be more than 0.1 volts more than the rest of the batteries, the rest of the cells, to actually get shunted. Minimum temperature is irrelevant, max temperature is relevant. Now, max charge voltage, that's the voltage the charger will go to. 148 volt is about where we want to be. Maximum charge current is the maximum output of the charger. I've got a TC charger in here and I've got heavy wires attached to it, so 20 amps is fine. You can set an alternate charge voltage, but that's not implemented. Basically, you can put a switch somewhere that lets you switch to charging fast or slow. Sleep delay is 5 minutes, so that's when it's in idle. MPI function. None of the MP functions are used, but one parallel string. We're not doing pre-charge. We're not in stationary mode. We want brightness to be 100% because the display is pretty dim. Buzz is just the beep. Given that we're not showing temperature anyway, it doesn't matter whether you're setting to Fahrenheit or Celsius. State of charge display is in percent, but you can pick amp hours instead. It depends what you're sort of more comfortable with. Personally, I prefer amp hours, but most customers prefer percent. Now we're setting up BMS, so that's where you're saying each module, how many cells are attached to them. So generally I use module IDs 0, 1 and 2 with 12 cells each. And that's really it. And go exit setup. I'll turn off at this point because I've just noticed that on each module they're all set to be module 0. which will cause some problems if I don't fix that now. Lost my little screwdriver again.
Okay.
So for clarity, I normally have the module that's negative most to be 0, and then the middle one be number 1. And the end one being number 2. Perfect, and then we power back on, just make sure that it actually worked. And that's good, it shows 125 volts. I'm going to kick it into drive mode. This is the screen you see while actually in ride mode. So pack voltage, pack current, amount of power you're drawing. You show auxiliary voltage, static charge percent, and this bar graph goes up and down, and the isolation, which is how good your isolation is between battery and ground, which at the moment it's 100%, so it's good. It's a touch screen, so you tap to the left, you can see your cell voltages. So this pack is what you would refer to as fairly well bottom balanced. That is there's not much cell variation at low state of charge. 3.545 volts and 3.51 volts, it's quite low, maybe at 10 or 20% state of charge, probably 10%. You can see every single cell voltage if you so wish, but generally you're only really to see what's your highest, your lowest, and your average. Okay, now I'm going to plug the bike into charge. Stop recording.
Yeah.
Okay, alright, to feed through, make sure your end cap goes on first. If you don't, it gets very frustrating because then you've got to take it all the way back out again to put it in. So I found out a second ago. Very tedious. There we go. And through there. So obviously the wire with just 2 wires in it, the high voltage, positive, negative. Brown to positive, blue to negative. Oh, why is that so tight? Negative. So the wires coming from the front of the bike for the 12 volt pickup off the back of the DC port. Positive goes to the switch in the middle, just plug in. Negative goes to ground, which is second terminal from this end. It's the easy way to describe it. CAN bus, again, just into the wired plug. Red, blue, white, black, starting from this end with the screws up. Just plugs in the bottom. Once you've stripped these wires, feed them in, again making sure the cap goes on first. All connections that you want to make have to be inside the box. So it should look like that. Yeah, stop recording please. Okay, so I've skipped ahead here a little bit. So when you're feeding the wires, make sure the wire going to the charger's on the right hand side, so that when it tilts up, it ends up on the bottom. Internally, earth you're just going to solder back together. I prefer to solder for this particular connection. For your live, on the side that goes out to your power point, you want to wire in the wire from the power supply, as in the live wire. The neutral will be joined, but with the neutral wire from the power supply, something like so. in this unit, I soldered on the wires for the lives. It might be a plug. It will come in as I might supply a plug. I generally find solder gives a better connection. Okay.